Now, digitalization, supply chain, in supply chain and operation decision. So, digitalization. First, let's talk about the industry revolution. I believe most of you know about industry revolution, and you also know about industry 4.0. What do we call industry 4.0? So, what happened? Earlier, we talk about the first industrial revolution, which is the in the beginning of the 19th century, where we were talking about the mechanism of the production process. So the factories, the industries were coming up with the production process, where we were talking about mass production and producing products and anything which we require. And you might have seen in construction as well, which when we talk about mass production, you might have seen the old houses which were built in the beginning of the 19th century. They got rows, which we also called red rose as well. So that was kind of mass production. You are producing houses, houses, and houses, and same thing was happening in other type of production as well. For example, salt, sugar, or any other product we would talk about. Even though I think last time as well, I given an example that when we talk about manufacturing, for example, cars, we only used to have maybe one model or one set specification of a car, and they didn't have any variations in it. But nowadays we got 4 or 5 variation on each model of the car. For example, if we talk about, let's say, BMW X5, they might have spec 1, spec 2, spec 3, spec 4, and spec 5 as well. So they have customized options available. Now, the first industrial revolution was about the mass production. The second industrial revolution, that was again about the mass production, but it was much more organized. And in a way that we have a conveyor belt, we have an assembly line, which is, for example, if you might have seen a video of the car production, the car is the body of the car is coming, and people are fitting the stuff on it, maybe doors, fitting the doors, the windscreen, tires, and the engine and all that. So that was in one assembly line. So that given a bit more opportunity to understand or to make the production process more efficient. And that's what happened in construction as well. When we came up with the standardized products, standard products that we can use or we can reuse in the construction. And then we got the third industrial revolution, where we have that started in about 1970s, where we came up with the computing technology and the internet. And that revolutionized the manufacturing industry, where we can use the computer and we can use the automation for manufacturing, where the human power was less required than the robots. But now uh, we have seen so far a significant improvement in the technology since then. So if we talk about the recent year, we came up with robotics, we came up with blockchains, we came up with sensors, we came up with big data, um, 3D printing, which is the additive manufacturing, and we came up with applications like BIM, where building information modeling, where we can collaborate all the suppliers, and we have advanced track and trace systems as well. So digital supply chain and industry 4, they came together with the advanced technology which can be used in construction, and it is being used in construction nowadays. Now the things like you might, if you are from the industry and you work on a construction site, you might know that most of the JVC cranes or any JVCs or any machines we are now renting or buying, they all have a data box, and they all have the Wi-Fi or Bluetooth connectivity as well. Now, that is what we call the Internet of Things, that we are now making an internet of the things, of the physical things. Now, each machine can talk to each other. if we have many machines on the construction site, they can talk to each other. We can send the command to those machines through a computer system or through a collaborative portal, for example, BIM or any other portal, application the company is using. And we can have for track and trace, we can have the RFID, or there are some new technologies available as well. For example, GPS technology, which use RFID as well. So we can use RFID coding or the trackers with the lorries. We can use those trackers with the material, and we know the exact location of the material and how long it will take to reach on the site or to reach to your warehouse as well. And we can use the cloud technologies to share the information and communicate with each other when we have a collaboration within the supplier or all the parties involved in the construction supply chain. So these are some of the technologies which is being used in construction nowadays, but not just construction, in all the manufacturing system. Remember, we talked about offsite construction last week, and we can use all these technologies, and it is being used in all the offsite construction sites as well. Now, additive manufacturing, which is 3D printing, you might have seen some of the examples of the 3D printing that we can now print, or we can now build homes with the additive manufacturing. Or if we have, if like let's say architects came up with a complex structure of something, or maybe complex design of the window or whatever, we can use 3D printing technique for additive to manufacture those products as well. And we can also use digital twins. We will talk about digital twins in a bit. So digital twin and use 3D printing with the digital twin technology. So digital twins is one is the design portal, for example, like AutoCAD or BIM or like Revit. So we can come up with a design, and we use the big data to improve the design as much as we can improve. And then we use 3D printing, which has a complex structure to be built, and we can use 3D printing for that complex structure. But at the same time, depends on how many we need to produce or how many we need to manufacture. We can use track and trace system as well. You might have heard track and trace during the COVID, which was an application which can track and trace the spread of the COVID through the application. So same kind of system, but obviously NHS system was fairly new. It didn't work properly all the time, but the other system, for example, having on a smaller scale for a construction site or for material, that will be much more efficient as well. So these are some of the technologies we are using, but at the same time, we can use uh, drones, automated vehicles. We can also use other different type of technologies available. For example, laser scanners, and using laser scanners with BIM to came up with the how much material we required, and to came up with the other components or the products we require for the construction. Now, for Industry 4, there is no unique definition so far. So there are many different ideas, but basically the main idea for the Industry 4 is that we are using or intensively utilizing machines, materials, and tools, our warehouses and other transportation, and they are all connected. They are all connected together with the technology, with the use of internet, with the use of sensors, and they are all connecting and they are all talking to each other. The basic idea is to create a cyber physical system where materials, machines, the component, they can talk to each other, and they can give the real-time information where they are and how long it will take to arrive at one place, or how long it will take to commute from one place to other place. And if there are any problem, any issues, then it can trigger the action, and it can trigger, it can flag up the issues as well, and it can come up with a solution with the use of artificial intelligence, because the system used the database and then trigger the action to be taken as well. So any problem, for example, a lorry is coming from the warehouse to the construction site, there was an accident on the road is blocked, then what can be done? So you got the real-time data, and the computer system, artificial intelligence can calculate how long it will take normally to clear the road, with from the clear the debris and all that, because that is an accident site. Is there any alternate routes? And it can give you almost real-time data, and that is what you might see when you use Google Maps, or when you use other like TomTom or Waze, and they have the live update, and it tells you normally there is a delay at this particular stretch of the road, and the total delay time is like 7 minutes or 8 minutes. So that gives you real time, almost real time data. I'm not saying that is absolutely accurate, because they, again, those are forecast, and forecasts are never accurate. So it could be 7.9 minute, or it could be 8.1 minute, but it says overall picture that it could take 8 minutes. So this type of technology can be used in construction, and it is all about adding the value to the process, and that will improve the efficiency, not just of the operations of the construction, but at the same time the entire life cycle of the construction project. So Industry 4, it is as an excellent opportunity for the construction, for the developers, but at the same time, it gives you much more opportunity to add value while reducing the cost, and reducing the waste as well. Now, it normally represents smart manufacturing, and as we talked about last week, that construction is a manufacturing site. Construction is the assembly site. So we're talking about the offsite construction. It gives us, it represents the smart manufacturing and a networking concept. Because why networking? Because all the suppliers, tier one, tier two, tier three, they have to come together. They have to connect with each other to come up with a super intelligent system that can use the artificial intelligence and grab information from all these organization, or all these people, and come up with the solution. So the future, in very near future, let's say, um, artificial intelligence will be helping humans, or even without the help of humans, they will be taking decision on your logistic systems, on your procurement systems, on your construction systems as well. What need to be done, when it need to be done, and it modifies your overall construction planning, overall construction. The monitoring and controlling is being done with the artificial intelligence as well. So it's not too far. Um, so as you might have seen in last 10 years, we have seen a lot of technologies, or a vast variety of technologies coming up, and it's improving day by day, and we are utilizing it, and we are improving it, improving our own production system through those technology. So, but those um, some of the strategies, or some of the terminologies we came up with, for example, lean thinking, that Industry 4 doesn't come as a package with the lean thinking. So there is no unison approach of Industry 4 with the lean thinking. So some of the people has came up with the terminology, which is lean industry. So lean plus industry 4.0. So we are using lean, but at the same time we are using Industry 4 as well. So we need to embed lean tools and techniques, lean terminology, lean thinking into the Industry 4 thinking and tools and techniques as well. And that is how it will work in a much better way. If we need to reduce waste, if we need to add value and become more efficient. So what are the enablers of Industry 4? Mainly Internet of Things, where we are creating a network of several things in the home, on our construction site. As an example, if you're using ring bell or you're using any Wi-Fi cameras, it won't work until unless we have any internet connection. And that can the CCTV cameras you are using in your homes or at offices, you can watch the footage or the video, live video on your mobile phone. So your mobile phone is connected with your CCTV camera. That becomes the Internet of Things. Nowadays, what we have, uh, we have a Bluetooth enabled and Wi-Fi enabled devices that connect with each other without the use of internet. So they have their own kind of internet connection between those devices. For example, there are many sound bars or sound systems available. You got wireless speakers, and those speakers connect with each other with one touch of a button, and which is called multi-room, Bosch multi-room or something like that. So they can connect with each other without any requirement of the internet. So they have their own internet connection, which is the Wi-Fi connection or the Bluetooth connection. Bluetooth is a bit old technology now. Most of the devices comes with the Wi-Fi connection. Even the dishwashers, washing machines that can connect with your mobile phone without the need of the internet, and you can just use it with your mobile phone. Some other examples, for example, Hive heating control system, and some other heating control system, which you can control the heating with your mobile phone, and it automatically starts when they know that your mobile phone is within 200-meter or 500-meter range of your home. So those are the things we can. I mean, this type of technology we can utilize on our construction side when we're talking about the cranes, JVCs, and any other machines we are using for our construction, so that they can talk to each other and there is no human being needed to operate those machines, and they can take the decisions themselves. But again, we are not at that stage that it doesn't need human at all, and there are it scares people that what will happen in that case, if the machines are being operated themselves, and there is no need of human being. But at this point, we still need human being to make sure the decisions taken by the machine is right for our construction project or any other project or any other manufacturing. So at least you need one supervisor or one person sitting there who can analyze the decision made by artificial intelligence. So that is the enabler of Industry 4. The other enablers, like the physical component, it could be machines, it could be any components, or it could be any products as well, which is connected with the intranet, and we need the connectivity components. For example, with you cannot use your ring bell, or you cannot view the footage of the ring bell until unless you have that connected with the internet or Wi-Fi connection in your home. So physical component work with the connectivity components, and we need the smart components, which is the ring bell or the smart lighting system, Wi-Fi bulbs, or any other lighting as well. So we need these three, which enables the Industry 4. The physical components on a construction site, it could be the JVC or any other machines whichever we are using for construction. We need the internet as well, sometimes maybe the cloud storage or maybe the data exchange, which can capture data and which can send data through the to the collaborative portals. It could be any cloud drive, or it could be something else, or it could be an designated server for that particular construction site. And then we need the sensors. We can have the microprocessors, data storage, and embedded operating systems as well. So we need all these things to enable Industry 4. That is important. Until unless Industry 4 is not going to work without any of these. Now we got a digital SCORM framework, which is called System Center Operations Management Framework. Now that framework gives us an understanding of the cyber supply chain and the physical supply chain. How does that work? So when we talk about physical supply chain, we talk about the traditional way of working, where we used to have suppliers and used to send material to the factory add value to the material and come up with a product. The product goes to wholesale, and the wholesaler was sending product to retail. So that was a push demand. The factories are pushing the products to the wholesalers, and wholesalers are pushing the product to the retailers, and retailers used to push the products to the consumers as well. And that is what we see in service industry nowadays. You buy a new dishwasher, after 2 or 3 days they start calling you. Oh, did you got it? Everything is okay, is working, is fine. Have you heard about the extended warranty? Do you want 5-year extended warranty? It's only going to cost you £5 a month. So that extended warranty, and wherever you go to Curry's PC World, you go anywhere else, they are just pushing that product to you because it is not in demand. No, people don't want that product. It is additional cost, because when we buy something, for example, I bought a dishwasher, costed me £500, and on top of that, it will cost me every day whenever I wash dishes. So there is a cost of electricity, there is cost of energy, there is cost of the water, and even the drainage as well. So all that cost, and obviously there will be, because that is a machine, there will be depreciation as well. So the cost of ownership, the total cost of ownership is different than what I paid upfront to get that dishwasher. Now, if I buy an additional, like for example, insurance or warranty, then what will happen? It will be an additional cost. So let's say um, my dishwasher will last for 3 years on an average. In 3 years, if I wash dishes every day, so 365 days per year times 3, so it's about more than 1,000 days. In 1,000 days, so 1,000 times, every time I wash, what will be the cost of washing? So maybe £2, £3, £4, whatever it is. So it will cost me for 3 years. The washing dishes costed me £5,000 if I calculate £5 per wash, and it's 1,000 wash. It will last for 1,000 washes. Now, if I buy additional warranty and I pay another £100 for over 3 years, now the cost will increase by £100. So that is an additional cost. So when we are pushing the products in the traditional supply chain, we got supplier pushing the products to the factory, and the factory to wholesale, and wholesale to retail. Now the things are different now. What is happening now? You demand for the being a consumer, you demand for the product. So consumers are demanding the product. Now factories only build or only manufacture something when there is a demand. Now, for example, I need a new car. I went to Honda, and I asked them, okay, I want a Honda Civic, and on Honda Civic, I want that particular spec with a particular color, and they take my order and they will say, okay, your waiting time is 3 months, and after 3 months your car will be delivered. So why that waiting time is? So the waiting time is because they plan for based on my specification, based on the point of sale data, because I went to the showroom. That is a point of sale. They feed all the data. Based on that data, they plan. Now, why they have to plan? Because what will happen? They will collect the similar order as much as they can, and then because they have a set specification, they have a choice of 5 colors. Now if I order black, so they will see how many other orders are coming for the black car, and they will plan for a day. In one day we only produce the black cars, because we don't have to change the colors again and again, or the paint again and again, or we don't have to change our manufacturing setup again and again. So the plan in that way with the sales data. Then they source the material based on that planning. In last 1 month, we got order for black cars with a white roof, or with the sunroof. Let's say sunroof. So with the sunroof, now they collect all the data and they source that many sunroofs. So they know how many sunroofs they require. They know how much paint they will require because it is black. Now they know how many sunroofs they will require. So based on the point of sale data. Now the system is totally upside down. It's totally changed. Now plan, they source the material based on what orders are coming in, and then they make the cars for you. And for that they require the sensors, robotic, 3D printing, or whatever they need based on the specification. I'm just giving an example of cars. It could be anything, it could be homes, it could be anything. So when we talk about off-site construction and you have a bespoke order or tailor to made, you go for let's say I need a garden shed, and the standard size of the garden shed available with a offsite manufacturer is 8 by 20 or 8 by 10 or 8 by 16. So there is a variation of 2 feet in every garden home. But my requirement is 7 by 20, and they don't have 7 by 20 as a standard. So that is a customized order. And this is what we are talking about, the mass customization, mass personalization. And that is the way the things are moving forward. So when we are coming up with a construction, when we are coming up with a product, either it's construction, a dwelling, a apartment, or maybe a design of a kitchen, we have to think about mass personalization. People want something which they are attached to. You want your own mobile phone. You can't share mobile phone with other people. Or you don't share mobile phone with other people. Nowadays, you don't share your laptops with other people because that is something contains your information, your any files or anything which is personalized to you. So you look for a personal device, and that is what we do. We look for a personalized home as well, a personalized office, and that is what happened. So we came up with the sales data, like the example I given you last week. Normally, the new built homes, they give you a shell. They don't put any tires. They don't put any paints. They don't put any, anything which is required with the interior decoration. And they ask you what color do you want. They have a choice available, and or maybe they have the subcontractor who can come and build it for you, and or they have a variety of choices. So you don't have to go around and look for somebody who can put up the bathroom tiles, who can put up the flooring, who can put up the kitchen, your bathrooms or the toilets, any decoration you need, and the garden landscaping work. They can give you a full package. Okay, these are the people who are attached with us. You just make a choice in our office, and we that is our job. We will contact with them and they will come and put it there. I remember when I bought my new home, so I given just They came up with a costing, and I given them the money, and that's it. So when I moved in, everything was ready. So that is how people want nowadays. If you buy, earlier, again, example of a car. Earlier, what we used to had is, we used to buy cars from outside, and then we used to go to a car accessory shop and buy the audio system and other accessories for the car. But nowadays, the system is totally different. You don't buy extra accessories with the new car. Maybe just mats, or sometimes that those people give you mats for the free as well, um, or that is within the costing of the car. So that is what happens. So is mass customization. Those accessory options are being given by the car manufacturer at the time of point of sale. They ask you, what do you need in it? You need 360-degree cameras, you need parking sensors, you need all powered windows, you need sunroof, you need all these. And then you get it, you give them order, they source for the material, they make it, they build it for you, and then they deliver it for you. And when they deliver, and whenever you call them, call the showroom, oh, my car is due next week, what do you think, when it's coming? And they have track and trace system, and they can tell you exactly your car will be arriving on Friday, and we can deliver it to you on Saturday or Sunday or whatever time, because they might need a couple of days for preparing it to deliver. So these are the things happening in digital SCORM framework. So it's a digital supply chain now. We got the point of sale system. We got e-procurement. We will talk about e-procurement. What is e-procurement? Supply visibility control. We can use the sensor, robotics, 3D printing, virtual reality. We can use artificial intelligence for the whole system. We're using the blockchain technology, where we are trying to keep the system as intact, or because there's always threat of of the dark web, and of the hackers and all that. So we use blockchain, we use RFID and GPS system, we use enterprise resource planning, and the advanced planning system, project planning systems as well. So that is what we are using nowadays, and it is all about big data analytics. We can't do anything without understanding, or without capturing and understanding the big data with the help of artificial intelligence, because the amount of data we have nowadays, it is not possible that it can be analyzed by a human being. Optimization and simulation. Then we optimize our process, and we can also use the simulations as well to create a factory environment. There are several applications. For example, AnyLogic. You can build a factory in virtual environment and see how many cars you can make in one day. Then change the layout, and then try to see it again. And is it going to increase the production rate, or is it going to increase the efficiency, or is it going to add the value? And then you change. Once you are satisfied with the virtual environment, you go and modify it in the physical environment. Same thing happen in construction. You come up with a virtual design, you check everything, what type of material is required, which products are required, which components are required, and then you came up with the costing, and then you put it in the physical environment as well. So all this is about the digital SCORM framework. That is a very good example given by Ivanov in 2018, and they came up with two different physical supply chain and cyber supply chain, how this is working. Now, nowadays, we are not working. If somebody or an organization is working on physical supply chain, they will die. They will, if not dead yet, they will die very soon. So we work on the cyber supply chain. We use all the tracking system. Sometimes the organization doesn't have the capability to spend a lot of budget or a lot of cost of finance on this digital supply chain, because some of the technologies are very, very expensive, but you can always outsource. Remember, when you want to transfer the risk, you outsource it and you give a package deal to somebody, and that's their responsibility in procurement. Now, digital twin is simply we're talking about a virtual environment. We're creating a physical environment into a virtual environment. Your architects came up with a design, and if the design is complex, you create virtual in a virtual environment, and then see what you can do to came up with those complex design. Maybe you use 3D technology, 3D printing technology, which is additive manufacturing, which add layer by layer to that product, and this is what is being used to come up with the complex products. And that the digital twin technology is being used by, you might have seen some, uh, some very nice designs of the cars, motorcycles, cycles, and all these products are coming up based on technology, or they came up. Those products are being designed in the digital environment, and then you being used. The 3D manufacturing, additive manufacturing is being used to came up with the components, maybe the body parts of the car. You might have seen the trims of the car is much more visible and much more. They have several designs. Each of the car manufacturer, each of the car model, maybe I think there is more than 500 or 1,000 cars models available in the UK. They all have different trims. They all have different look. So they are using the digital twins and additive manufacturing to came up with the complex product, which cannot be done by a human being, which cannot be done by a machine, can be done by additive manufacturing. And we have seen several examples. The additive manufacturing is being used to create the homes and um, to create to come up or to manufacture some of the components which are being used for construction as well. Now, e-procurement. So e-procurement, that is like e-catalogs, e-invoicing, and e-auctions. So we are all doing everything based on the internet, and we're coming up with the catalogs, we're coming up with the invoicing, and we nowadays we have systems available. For example, enterprise resource planning. So we have systems available which can connect together and create the invoices and create the purchase orders and create other type of documents, maybe the contracts as well. It is all automated, and it also send information to HMRC for the VAT, how much VAT is collected, and to your accountants, maybe how much what has been, how much has been spent. It is synchronized with your bank statement as well, so that it can grab information from your bank statement that it is being paid or not. So everything can be done in a virtual environment. So there are several applications available. If you might know some of the names, for example, Sage, for example, several invoicing application that can connect with the QuickBooks, and that can send information to your suppliers about the orders, and that can get the information from your supplier about the deliveries, and the document required and the payments as well. So I give you an example. I remember some of the companies like home stores. You used to have BHS, New Look, Primark. They all work on invoicing, e-procurement system. So they have their own portal. We send information to the supplier that okay, this much product we have in inventory, that will last only 3 or 4 days, and we will need more items within 3 days time. So it sends an order automated order to the supplier, or at least the information so supplier knows how many products they need to manufacture within 3 days or 4 days time. Same kind of stuff is being used. Remember, we talked about a point of sale system. So that is point of sale system, which we see the till in the stores where we go and pay, and they scan the item and it marks the item it is being sold, and it automatically calculate the inventory, how much inventory is left within the system or within the store, and then it send the order to distribution center. And if they don't have a distribution center, it send the order to the factory. It depends if they are going to continue the product or not. So all these things can be done with the e-procurement system. E-procurement system can also suggest you the best supplier. Let's say if you got more than one supplier for the same item, based on the data, based on the deliveries, the schedule, the cost, and their performance, the benchmarking performance, it can send the order to the most suitable supplier who can deliver in how much time, cost effectively, and more efficiently. So we use e-procurement system for that. Now, supplier collaboration portals. So where we collaborate, all the suppliers come together. They can feed the information, they can view the information, and they can get the information from that. So building information modeling, BIM is kind of a supplier collaboration portal where all the suppliers and the component suppliers, maybe tier 1, tier 2, tier 3, they can come together and they put the information all together, and everybody have the information at the right time at the right place, so they can make a much better decision. They can forecast, they can plan well, and they can monitor the value added activities as well. So supplier collaboration portal is kind of them. Now, as I mentioned earlier, that like industry 4 doesn't come up with a package deal as with lean. So Leandustry is another name people came up with, and how that worked towards the industry 4. Remember when we talked about lean earlier, and we are going to talk about lean a little bit today, but if we are going through with these slides, I won't cover it later on. And that could be an important topic for your assessments. So in lean principles, we talked about that we try to reduce the waste, unwanted activities from any of the process, and we try to add value while reducing waste and not non-value added activities. And at the same time, we try to increase the flow of the products and the flow of information. And also we try to apply pull and just in time or Kanban kind of tools and techniques to lean. Also the continuous improvement, and we seek perfection and robustness through continuous improvement until unless we reach to a point that it cannot be improved anymore. And we try to manage the people and the people involvement, team working, practical problem solving. That is all are the lean principle. But the main 5 lean principle we talked about: adding value, reducing waste, improving the flow, continuous improvement, and and using just in time and pull technique. Now, we also talked about 7 type of waste: Muri, Muda, and Mod. And in 7 type of waste, we have Muda, which got these 7 type of waste. Remember, we talked about 8 type of waste, which was another one was skills. So transport, which is Timwood, TIMWOOD. So 7 type of waste we try to reduce in any of the process. And to do that, we can use the industry 4, which can help us to increase data availability, analyzing the data, simulating the performance, how we can do it. So for example, if we want to reduce any activities in transportation, we can go into a virtual environment and see how can we reduce it. we try to increase or decrease the frequency of the transportation, and it will analyze the data and give us the optimum figure. What is the optimum frequency, or what could be the optimum frequency of transport coming in and going out from the construction site? Inventory, same thing. We can do for inventories. Same thing we can do for motion, waiting. Everything can be done in the virtual environment if we seek perfection in whatever we are doing. Either is e-procurement or is logistic, or we are trying to monitor and control any of the process as well. So all these things can be done through Industry 4 or using Industry 4. So lean and industry, so lean industry 4.0, and we come up with the technology, which technology we can use to reduce those 7 type of waste, add value, and achieve the perfection in whatever we're doing. Now, potential and advantages. So again, those 7 type of waste transportation, which can give the real-time data, can be used for transportation, route optimization, improved fleet utilization, and additive manufacturing. Manufacturing lead to the data exchange instead of the part shipment. Or we might use those 3D printers or 3D manufacturing techniques on site as well, where we just need to bring the material, and machine is producing the products or the components on the site itself. Inventory, um, that obviously, like the example I given you, it can be calculated from the point of sale. So as soon as something is being consumed or something is being sold or being used in the building, it calculates the inventory and it gives the real-time data how much inventory is left. Motion and movement, we can do the simulation, and AI augmented reality can analyze the site office. How long will it take from one place to go to site office, point A to point B? Is there any risks? Is there anything we need to do? Can we reduce that motion or excess movement? Where is the the entrance and the exit to the site? How can we improve that if there is any excess motion of the vehicles from entrance to the exit? So all these things can be done. Waiting time, is there any waiting time? The data can be analyzed, and we can utilize the robots, we can utilize the 3D printing. If the waiting time is too much, the components are coming from, let's say, from China mainland or from any other place. The products are coming from there. Can we have a 3D printing system on site and develop our own component, or maybe in an offsite construction site? We can that can be done as well. That could be a most cost effective or cheaper option. We buy a 3D printer one time and use it over the years for several different products. Several different projects. Overproduction, when we have more accurate sales data through POS, we know every day how many we are selling, then we can calculate how many we need to produce. So we always look for the cash cows. The cash cows means our fastest selling products. And remember that if you look at the Pareto's 80-20 rule, if you got 100 items, 100 different products in our store, only 20% or maybe 18% or somewhere nearby 20% is going to be cash cow, which sells really fast, very quickly, and we make us good profit on that as well. So we focus on those cash cow products. So when we know how many we are selling through the point of sales, we can accurately come up with a forecast and just manufacture what is required. Over processing, smart factories, it reduce the possibility of over processing on the production or any rework, because remember we talked about the quality total quality management. And in quality management, it is checking, all the machines are checking their own quality. And if their quality, if there are any variations or anything, then it will stop production or it will try to adjust itself, because it is using the real-time information. It is grabbing the data, and it can adjust through the help of artificial intelligence. It can adjust themselves. So when we talk about the variations and over processing, so what happened normally, machines get heat over the time. So they have a running time. Maybe it can only run for 18 hours continuously in within 20 hours, 24 hours. So what will happen? And that machine will need some time to rest as well. So there are some machines. So let's say you are making iPhone screens with the machine, or iPhone covers with that machine. So what will happen with that? After certain time, certain period, the machine will give some variation. And if the that variation could be in a friction of a millimeter. So that is possible that that friction of millimeter will increase over the time. So you need to stop where it start giving the variation. Otherwise, the cover won't fit the iPhone. And that is what happened. If you are producing some complex component and there is a variation, it won't fit. So the example I given you earlier, the USB or maybe any jacks, maybe the wire or the chargers, it doesn't fit each other if there is a very tiny friction of variation. And that is where we check the quality at each stage of manufacturing. And that will help us to reduce the over processing as well. And we try to find any defects so we don't have to rework. So there is some potentials and the advantages. So that was about digital supply chains and how that can help in construction and any other type of manufacturing. So let's